All right, now we're on page 65 of your workbook. We have example 5.19, mixture problems. One solution contains 20% acid and the second solution contains 50% acid. How many ounces of each solution should be mixed in order to have 60 ounces of a 30% acid solution? So this is a good review of those kind of dreaded mixture problems you had in chapter 4. I think sometimes with chapter 5 and doing it as a system, the light goes on there a little bit more and it's easier to kind of set up and wrap your head around in a sense. So first thing, we're going to declare our unknowns. So what we don't know is the number of ounces of each mix. So that's what we're going to find of each solution, right? So we're going to let X equal number ounces of 20% solution, and we're going to let Y equal number ounces, ounces of 50% of the solution. Okay. Well, 20% acid solution is basically what it is. And then we're going to set up our system so we know that the number of ounces of the 20% acid, just write that in there, plus the number of ounces of our 50% acid equals our total number of ounces, which is 60. So again, we're setting up a system. That's our quantity. Now we're going to do our kind of value, so to speak, our actual, when they're mixed together, what they're going to look like. So we have 20%, so 0.2x plus the 50%, 0.5y equals our total times 0.3. Don't forget to do that. That's really important because that's the total times what we want to have is the 0.3, 30%. So now I'm going to do this one as the elimination method again, just to review that. So you saw me do that in the last video if you watched that. If not, and you did a different method and just moved on, that's totally fine, but let's check it out here. So first thing we want to do is multiply this by the opposite coefficient of one of these. So I'm going to pick negative 0.2 to distribute through. And then I'm going to rewrite that over here. So I have negative 0.2x minus 0.2y equals negative 0.2 times 60 will give me negative 12. And then this one I'm just rewriting 0.2x plus 0.5y. And again, you can pause this and do it along, kind of just check back. Alright, so now we're going to add these together, and these cancel out or eliminate, right? The negative 0.2y plus 0.5y gives me 0.3y. Negative 12 plus 18 is going to give me 6. And then I'm going to divide both sides by 0.3. And I end up with y equals 20. Which makes sense. So sometimes if you get a negative number there, you just know something went wrong with the signs. You have to double check your work, or maybe have things turned around in an odd way, like with your percentages, your declaration, or something like that. But usually it's because of a negative situation up here, because you should have a positive value when you have a number of ounces of something. So now we can just take that, right, and we're going to plug back in up here. You can just do that in your head, really. So we have 40 would be the leftovers. I mean, you could go through and eliminate the y's to find the x. That's a legit thing to do as well. Some textbooks always make you do that, but I don't. I think it should be a choice. So here we have, I'll just kind of do it out quick. X plus 20 equals 60. Therefore, x equals 40. So then our answer is going to be, as a point, we would write it as 40, 60. Okay. Just so we know, like, those are in the values. But then we also need our sentence. So go ahead and write that, and I'm going to pause and write that so you don't have to take time to see all that, but you can check it. Okay, so as I was writing my sentence, I noticed I wrote a 6 there instead of 2. So that should be 20. We need 40 ounces of the 20% acid solution and 20 ounces of the 50% acid solution. So that makes us come full circle with all our pieces. So we have A, we have B, we have C, and we have D. Now I notice some of you, as you're doing your homework and quizzes especially, I want to see this, is I give you points for following the directions. Like there's usually some kind of buffer in the overall point scheme. So that comes for if you're labeling and declaring all these pieces. And some of you are really listing out the A, B, C, D. And I think that's important to do. I usually write it at the top of all the directions. As we move on and as you go higher in math, you should just know that's expected. You're not going to necessarily be given that as a direction, but you are going to be expected to do it, or you're not going to get full credit because it's graded on a rubric. It's not just like, oh, pop in the answer. We do that for the electronic homework. I mean, you get credit just for your answers. So it is a balance, but do make sure you're writing it out. That's why I take the time to do all the paper stuff, because I want to prepare you for what's to come in your future. Okay, so that's it for this one. The next problem is example 5.20, and you can either try that one on your own as classwork. I would really suggest that. Set it up as a system. You can do it by any method that you want to try. You could try the elimination method. You could try substitution. I think I do this one by substitution. It does have a little twist, I think, on it. So you got to pay attention to the problem. How many pounds of tea that costs $4.20 per pound must be mixed with 12 pounds of tea that costs $2.25 per pound to make a mixture that costs $3.40 per pound? Okay, so it's a little bit different what we do know and don't know the layout wise of compared to the first problem. So if you can pause at any time and finish up the problem on your own, but I do want to make sure that you're set up here. So check back. If you pause it now, check back to make sure you get the first piece. So how many pounds of tea that costs $4.20 per pound? So I'm going to let that equal X. So let X equal number of pounds for $4.20 tea. Okay, so the first tea, okay, must be mixed. So this is the more expensive tea. Must be mixed with 12 pounds of tea that costs $2.25 per pound. So we have all of this already. So this is going to be like our 420x plus, we have the 12 times the 2.25 is our value of the overall cheaper tea. But what we don't know is how much we're going to make, total. Okay, so our Y there is the total pounds. So a little different. And I think in this case, sometimes this one's just easier to do the old way we did in Chapter 4, but I do want you to go through the process of trying to set up a system. So again, we have our quantity value for our system is going to be x plus 12, because that's the number of pounds for the more expensive tea plus 12 pounds of the cheaper tea equals y, total pounds. So that's tricky because we're used to going x plus y equals a number. But in this case, that's not what's happening here. And then our value equation is the 420 or 4.2x plus 12 times 2.25. Actually, I'll make it match. 2.25, so that's my cost of that tea. I have 12 pounds of it. Okay. And then to equal 340 or 3.4 y times my total. So this is my value. So now all I have to do is solve. So I'm going to go ahead and solve by substitution. Y equals x plus 12 already. Nicely done. So I'm just going to substitute that in here for y. So then I will have 4.2x plus 2.25 times 12. I'm just going to go ahead and calculate that out. That comes up to be 27 equals 3.4 times x plus 12. And then I distribute here. I combine any like terms. I just do my solving process. So go ahead and pause and do that, and I'll finish this up here. Okay, so I did the math here. Just subtract the 3.4x from both sides, get 0.8x. Subtract 27 from both sides, get 13.8 on the right hand side. Divide both sides by 0.8, and I get 17.25 or 17.25 pounds is how we would word that. So what is our question asking? It's saying how much do we need to mix in? So we don't really need to know the total. We just need to know like what we're mixing in. So our answer would be we must mix in 17.25 pounds of the more expensive tea to get the mix we want. Okay, so there's your answer. Again, all the parts, we have A, B, C, and D. Okay, that's the key thing. LBS is just an abbreviation for pounds, or you could do PDS or write out the word pounds. It doesn't matter, that's fine. Okay, so I think we're almost done with this. We have a couple more problems on the last page here. I'm going to do those in a separate video. They're uniform motion with unknown rates, which again, that's kind of challenging in general, but then we add the twist in of upstream, downstream, and or any kind of wind resistance and things like that, and it gets pretty tricky. So I'll show you some specific things for that. So just look for that video. That'll be part 3.